Hi everyone, thanks for coming to the core seminar today. So today I've invited Jaron Chong. So Jaron is a radiologist at the MUHC that I'm not sure most of you know, or some of you have probably crossed paths with. So his main interests are in, he did an abdominal fellowship at Yale,
Yep.
right? And he's appointed as an assistant professor. He just completed a master's in health informatics at U of T. And he's interested in appropriate utilization, and he's going to talk a little bit about sort of the interface between clinicians and radiologists to improve healthcare utilization. He has a particular expertise in natural language processing and image analysis technology, so he will give us an overview of what he's been doing during his master's.
Okay, sure. Thank you so much. All right, thanks guys. A little bit of a audio echo up there as well. So the talk is titled Radiology and AI, Natural Language Processing and Image Analysis Technologies to Assist Outcomes Research. So I think that's appropriate for core. We're going to cover a few different topics today. So just by way of introduction for myself, I think Nicole already mentioned a few things as well. So my daytime job, actually my job right now at this moment, I'm scheduled at RVH Ultrasound. I do ultrasound work and CT work and MR work and so forth. So I'm in the abdominal division, so that's kind of my clinical practice. From the research side, again, there have been a few research teams that I've been involved in. One is in appropriate utilization of medical imaging, with some of our earliest work more so on CT pulmonary embolus, CTPE scans. And more recently as well too, we've been trying to develop a little bit more of those technologies, not just on the language and the text side, but also on the image processing side as well too. So these are the more classical radiology plus AI things that you hear about, where you try to get an image, make a diagnosis, make a segmentation, make that sort of a thing as well too. So it's kind of my two halves from the research perspective. And I had to reflect a little bit on what I wanted my objective to be for this talk. And so this is kind of like my one main thesis that I want to convince you guys of during this, which is, and this is a very personal statement, okay, the way we're doing things is wrong, and we have to look outside ourselves to do better. And I'm going to get into exactly what those words and who is the we and the pronouns, and so I think those are very important right now to try to define. But this is the key theme and the message that I want to get at by the very end. And the second idea that I want to get at actually is regarding the concept of intersections, right? Because I've talked about there are different components of what I do. There's the clinical half of what I do. There's the technology part of what I do as well too. And I often kind of feel that when you can actually bring your own kind of skills and talents and experiences, right, that can come from anywhere, not necessarily just within clinical, but with elsewhere as well too, that those sort of intersections are what create new and novel or interesting ideas. So the overall outline is kind of 4 or 5 different stages here as well too. We're going to talk about one specific research project, CT pulmonary embolus angiography diagnostic Vield, and we'll get into what that means exactly. We're going to actually start critiquing that because there's a challenge here in terms of like the way that we had done it is one way to do it, but maybe there's a better way to actually go and revisit the entire project. We're going to talk about the language half, which is more on topics like keyword search, NLP, natural language processing, and sentiment analysis. Then we're going to talk about different, on an opposite side, a very expansive idea of how maybe you could apply some of these concepts to search images, as in can you actually search images for outcomes as well directly, and then we'll conclude on that as well too. So first topic, pulmonary embolus, angiography diagnostic Vield. So I've made very few assumptions here regarding kind of background clinical knowledge and so forth, but there's a disease condition called a pulmonary embolus. Basically, it's a clot. If it were to lodge from, let's say, something distal down, you have a leg clot, for example, it progresses proximally, right, and actually lands within the lung. You can actually have ischemia and damage towards the lung, a very severe condition, as pictured by our nice little diagram here as well. Now, the overall quotes, if you take a look at US literature, 1 case per 1,000 person years, right? So that's about the frequency. So not a very frequent event, right? But when it occurs, extremely, or can be very devastating. I went back in the historical literature. So from 1982, this is like a very old article regarding like the benefit of anticoagulation. So if you try to dissolve a clot with medication and so forth, right? Your mortality could be up to about 35% if you didn't treat it. Okay, so you can imagine that you're in hospital, you have presenting with some other symptom, maybe some undifferentiated chest pain or difficulty breathing and so forth, right? And you could pass away in the hospital. That's how severe it was at that time. And there was a whole, evolution. I'm not the most qualified person to speak on this particular topic as well, but there was a whole evolution towards of, number one, trying to diagnose this disease condition, and number two, obviously handling the therapeutics and the management of it. If you go into the radiology literature, there was a very important event, right? Which is actually the first radiology article from 1992, which basically talked about validating the usage of a CT scan. So something, it's actually an out-of-date term nowadays, but a spiral volumetric CT scan of a single breath hold in order to basically diagnose PE. And they were comparing it to the prior gold standard at that time, which is pulmonary angiography. Angiography being almost kind of like a chest x-ray, but where you actually have to pass a tube almost like down into the veins as well, and actually pump the dye directly in. So it's much more invasive of a procedure as opposed to just doing a CT scan where the contrast is injected distally or peripherally. So this was the first event in 1992. And so very quickly, from the traditional kind, which you see there on your left for pulmonary angiography, to this intermediate state involving nuclear medicine and VQ scans. These are kind of like the very old vintage style images that you're seeing there in terms of that area that you do not see, the black points and dots, that's the infarcted area, to the more modern day 1992 CTPE scans, right? This took a long time. It took a lot of engineering, a lot of work, a lot of validation, a lot of experimentation. But at the end of it, we came up with a much better and less invasive diagnostic standard. And so if you go back into most like cardiology literature and other literature as well, to talk about mortality and so forth and what had happened over that time, right? If you look at the age-adjusted PE mortality per million persons and so forth, right? There were dramatic improvements. So from about 1992, when the technique was first invented to when it was implemented, I think at the Montreal General, with the initial site as well too, also later on with the Vic as well, you had dramatic increases in ability in terms of diagnosing. I was told stories about how in the late 90s, when the technique was first implemented, actually, it was a staff read examination, meaning in the sense that if you wanted it read, you couldn't get the resident on call or a trainee to be interpreted. As well too. You had to go, page up, get the full-on staff. They would go in, either come in the hospital, try to check it out and read it as well too. It was that advanced of a technique. Currently, right now, you can be a resident on call in your second year and so forth. You're going to get, like 5 or 6 or 7 of these all of the time as well too. So a lot of things changed rather quickly from 1992 to present. And this is all the benefit. And the graph looks wonderful. You're now down in the bottom right corner in 2015 and so forth. Of course, everyone lives happily ever after, right? And there's a second half to this story, which is the appropriate utilization half. And I just started pulling out random articles from various different locations and so forth. So this one's from, I think it's Edinburgh Medical School as well, too, talking about utilization. So you look at the years there, 2008 to 2015, and you go number of scans performed within a particular surveillance period in time. You go from the 40s up to the 70s, up to the 80s, up to the 90s, okay? This one is from actually New Zealand. So it's a review of adherence to guidelines for CTPA. You look at the volumes again, number ordered, 136, 169, all the way up to 301 in 2012, very, I guess like a boom year for CTPE. And then you look at as well on the more interesting on the right-hand side, which is the positive rate. So just to define that, because sometimes I get questions about what does yield mean. Positive rate meaning, so of the tests, let's say we order 100 tests, right? How many come back as positive? What started out in 2009 at 39%. Think about that, like half the scans that have some sort of finding and so forth, eventually steadily decayed itself down to about 18% by the time we reached about 2014. And this came out on Twitter about 4 or 5 days ago. So this actually is from the NYU, actually. So the PI here is Andrew Rosenkrantz as well, too. And I want to read that quote out on the right-hand side, right? This was actually a retrospective review of CMS, almost like CPT codes and procedure information from 1994 to 2015. So between 94 and 2015, ER utilization, emergency department utilization of chest radiography and CT raised by 173%. And 5,941.8%. And then if you look at the per 1,000 ED visits as well too, you went up by 81 for chest x-rays, not so popular, and then you get 3,900. I don't know how many times I can talk about topics and subjects where we have an increase of 3,000%. I don't know when you ever talk about numbers like that as well too, right? But if you actually go and look in these articles and the charts, that's what actually ends up happening as well too. So this is a very age-old story, right? It's not a very special story, I don't think, right? You have the earlier half, which talks about, you have improving technology, greater sensitivity, better diagnosis, all of the miracle story of that. And then you have the other half, which is like, when you have greater availability of technology, it results in overutilization, overdiagnosis, the unintended harms and effects that happen from that as well too. And it always seems sometimes it's cyclic. It bounces back and forth between these two things. And so there's a very natural question you could ask directly after this, which is, what is happening at MUHC, right? So this is where we get a little bit more sense. I think we're debating whether to record the lecture or not to record the lecture, and this is where we get into something a little bit more interesting as well, more personal as well too. But I think we're going to be very fair with what we're going to say here as well. So we wanted to answer some very basic questions, right? I just wanted a number. So you saw the numbers earlier just now from the New Zealand paper and so forth, about 18% or 39% many years ago and so forth. What is the positive Vield percentage at MUHC? And we had a guess. We had some ideas. It's very funny if you actually talk to a bunch of radiologists. You get the survey of like, what do the chest people think? What do the abdomen people think? And so forth as well. And we, like if you think about it, it doesn't sound that hard of a project to do, right? Like you get a list of every single PE scan, you sample a time period, whatever you can do. You read them, do a chart review, count the number of positives and negatives, get a percentage point out of that as well too. And so that's what we did. It was a very small project, I think, but like just a research letter project. Special thanks to also Jean-Marc Troquet from Emerge, Emily McDonald, Todd Lee as well too. So people from Internet had helped us out as well too, and also our former chairman Benoit Gallix as well. And the article that came out, right, basically tried to answer the core question, right. And so before you read the fine print, drum roll please, right. So the number for MUHC is 14.3%. That is our yield. Okay, and if you know, I think if you're in internal medicine, if you're in the field and so forth, right, this is actually not too bad of an average number. There are some U.S. reports that go down to 10% to 5%. Like there are some other numbers that are out there as well too. So I think the core average number is a fairly decent average mean. 199 out of 1394. This is like a 2-year review of all different scans. But yes. Mm-hmm. That's correct. And so the positive is obviously an interpretation off of the report, right? That's very true. It's actually very hard to, are we going to do a pulmonary angiography on everyone to get a gold standard to verify all these scans and so forth, right? It's definitely a surrogate measure. And that actually concerns us for a bunch of reasons actually as well too, because, if it comes off of a tone, with a sentiment, like from an NLP side of being positive as well too, there are a lot of unintended effects that will occur from that. And this is more so, I guess, within like Emily and Todd's domain as well too. And they've actually done a lot of follow-up work from this initial audit as well, looking at were the patients anticoagulated, were there any complications from those anticoagulations. There was actually a follow-up article that came up after this as well too, looking at some of those specific questions. And some of the evidence is going towards, if you have a questionable finding, like we run into this from radiology side a lot, where there's some breathing artifacts, some little motion or blur, and you're not sure, and you create a very uncertain report as well too, right? That maybe in those circumstances, it may not be fully appropriate to run through the full anticoagulation protocol. You have complications that you occur as well too. And so we're trying to figure out, number one, internally, what is the repeatability? And there's one ongoing project that's addressing that. And then as well too, the follow-up outcomes, which is what happens to the patients after you put out a positive or a positive sounding report, I think is a very important question as well too. So this was just more so, but this was early days. This was maybe back in about 2016 to 17, about 2 years ago when we had looked at this and said, we just want a ballpark number. How bad are we? How good are we? And so forth. And this was the number that we came up with.
Could I also ask about the time element?
Yes.
Does time matter when at what time you take the reading?
Does the time matter in terms of the reading? So the analysis for this project was off of obviously the final daytime final report, the final clinical report. Yes, correct. Yeah.
So does it matter if the patient's been there a day, 2 days, 3 days? I mean, I don't know hours. I mean, I don't know what the time element is.
So a lot of those details, especially with the initial presentation and so forth, right? They're actually challenging to be able to analyze, right? You're looking at basically performing a manual or a full-on chart review of the entire longitudinal record, which means initial presentation, initial onset of symptom, when they present to emerge, and all that kind of timeline stuff, right? So quite a bit more complicated as well. So this was again like first pass, look at the reports, right? How many are positive and negative, and so forth. And we've tried. I'll actually get into some issues about what happened when we tried to extend into some of those areas as well. So this is our number. But this wasn't the only focus of why we had intended to do this. We wanted to start with a ballpark number, but the more important thing ends up the second topic, which is interphysician practice variability as well. And this is a very sensitive topic, but this is the core table that's within that research letter, which is basically the very short sentence here is physicians with more orders have or had or at least there was a correlation, it seemed, right, with lower yield. So what you have here on this table, basically it's a stratification along kind of the rows there, right? You have the number of examinations that a physician ordered, an individual physician ordered during the observation period, right? And you have anything ranging from about 1 to 10 versus all the way up to about 53, 56, and so forth, and all the various stratifications. And then within those cohortings, right, you basically count how many positives, how many negatives, right? And if you look at those, see where that orange arrow is right there, right? So 20.7 and go all the way down and so forth. forth, right? It's pretty much a stepwise decline, 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 decline. Okay, and there are many reasons for this. There are many possible theories for this as well too, right? So like we were trying to actually figure out like what were the other relationships with lower unit examinations. We examined other properties as well too, like did 2-year versus 5-year matter? Did the seniority of a person matter as well too? Was there different, I guess practice patterns and things as well too, right? The frequency and number of orders was by far the strongest actually out of all the different various relationships. So that became our major headline, or as I like to kind of like briefly summarize, right? The harder you look, the less you find. So that's like the summary of it as well. And so interesting project from our perspective, right? And we're trying to work on additional hypotheses in relation to this first comment as well too. But I'm not here to talk about the PE project in and of itself, right? I'm actually here for a process. There's no PE in my title of the talk, right? There were a lot of things and lessons learned from this project that I want to discuss now regarding like how can we actually run these kinds of projects a little bit better. And we're getting to the initial hypothesis, like what does this sentence very specifically mean? Because this one project, a research letter, not a full article, right? One research letter took 1 year, okay? And that's from the inception of the initial question itself to the data collection, doing the initial audit, sorting out what was positive, what was negative, doing consensus meetings and things where we disagreed, blah, 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 all the way down as well to do the analysis, submit, like edit and all that kind of thing, right? I think this should take 30 minutes, okay? And we're going to talk about how and what we need to do in order to get it from that 1 year to the 30 minutes. Because it doesn't make any sense to me that this is a very complex question. It's every department should know what the percentage rate is. So is there a better way? Okay, so if you remember back from grade school, I don't know, like your grade 7, your grade 8 class and so forth, you always have this, the scientific method, you define a question, hypothesis, collect your data, and so forth, right? So everyone's seen this. I think every grade 7, homeroom has some sort of poster that looks along those lines as well too. My comment on this is that if you take that method and you try to rewrite that process and do it to scale, right, it kind of looks like that. It's not exactly the same size as well too. We expend a lot of energy and effort towards the collection of data, the curation of structured information, and then the fun part where you do your analysis, you try to figure out whether you're right or wrong, what is the actual yield, what is the actual number. That happens at the very end as well too, right? And sometimes I think if you're a little bit wiser, you spend a little bit more time on the question, right, and the actual background research as well too. So this is maybe not is the most experienced way to run about this process, but from a novice perspective, people can empathize with this sort of distribution of the various steps as well too. Now, anybody that was around in 2014 and 15 and 16, all of the hype about big data, so prior to all the deep learning and all the AI stuff as well too, you oftentimes there'll be a slide where they put something like this, right, where you have structured data, you have unstructured data, and it's exponentially growing, and we need lots of hard drives and all that kind of thing as well. So this is a very common concept, and if you're not familiar with unstructured data as well too, so the stuff that we curate in a very structured format as well too is very useful obviously for outcomes research and so forth. But unstructured data is like a radiology report. We don't tag it, we don't use the same vocabulary, it's not controlled, right? And it's much harder to extract information from these sources. And so if you look at what is the traditional medical or clinical response to unstructured data, I will cynically respond, medical students, right? So, or an army of medical students as well too. I have some very great people that are working with me and that's how you go from unstructured to structured. I was that medical student at one point. I spent summers at night like in chart review and so forth, right? So that's one answer. If you have a little bit more money, you can say databases, right? So you can have some sort of database, you submit a grant, you get something along those lines over there, right? And if you have a lot of money, you can create a data warehouse, which is maybe multiple databases combined together as well. And so this is the process. This is the technology element of it as well too. But there's an argument I'm going to make. This is from a clinical side, it's from a radiology, from a technological bent as well too, right? That a lot of these abstractions, they're distractions from the actual process. Because from a very practical matter, as an individual researcher, I don't define it in terms of like I like the technology. I really like the technology a lot. But for me, what I find is more important really is like what are the tasks and functions that I can do and I cannot do practically. Right? So if I want to figure out, how many scans are there, or can I sort out positive and negative, or can I access this, or can I find, let's say, every scan that was with contrast, and then, within the next few days or few hours later, there was a rise in creatinine. How do you sort that out? Can I get that, or can I not get that? And I think as an individual researcher, from a lot of perspectives, right, you will invariably answer a lot of the times, no, I can't, or do you know a person, or how can I, these are the common themes that keep on occurring when we attempt to do these kinds of research. So tying it back very concretely and specifically back to the PE project, right, we found very easily that we could find a CT chest or thorax report anatomically. That was, do a quick query in PACS, right, that's pretty straightforward, right. Exporting the full reports, we have direct kind of RIS access to our reports, so that was pretty easy as well too. too. We were worried about inter-rater consensus, so we ran some almost like internal kappas to see if people would even agree or disagree that a report was positive or negative. Those went pretty well as well too. But there were a lot of other tasks that were substantially difficult, things that we were actually incredibly surprised by. So for example, defining which report was actually a PE scan. Now that sounds like a very trivial thing to do, and so forth. We didn't have direct access to financials and billings and codes and so forth, so we couldn't necessarily use that. There was a lot of vocabulary that was held in common between CT chest with contrast reports for cancer staging, for example, right? Versus what you would see with a PE scan. There were inconsistencies in the reporting and so forth. So that relevancy, like, do I even define the cohort of reports? That denominator was actually a very challenging task in order to run this audit. Trying to create an algorithmic definition of positive and negative was actually incredibly non-trivial. It took a lot of iterations to even get something semi-working as well too. The key issue with that is that I would say that radiologists are very good at vocabulary. They have it's like they were born with the sources in their hands or something along those lines, because for the concept, the disease entity here, an embolus, which is like a clot, right? There are many different ways to say that. So some examples that we ran into, right? So embolus or thrombus or thromboembolic or a clot, or if you're not sure, then it's a filling defect, and there's many different ways to go about that. And then on top of that, you have negation, you have no evidence of, and you can say no in a bunch of different ways as well too. So very, very, very difficult to get at that in a very automatic way. Some of our best efforts would approach about 90 or 95% accurate, even after accounting for all the variations. So my chairman's initial response to my difficulties with doing point number 2 was number 3. Oh, just look at the impression, look at the conclusion as well too. There are reporting stylistic differences between radiologists, where some radiologists do not give a summary or an impression as well too. So that was my first response back. So, well, yeah, you would think that everybody had a summary, but not everybody has a summary. So that was not a great way to achieve the problem as well too. We were very interested from an article perspective of trying to get a pre-test score, so like a well score, something very basic to figure out what was the test, what was the risk of the person before the scan was even done as well too. Did some retrospective review or chart review of just the ER notes and initial as well too, right? Not always consistently in the same location, or it would be scattered across various places as well. So not very easy to reconstruct retrospectively. And then the one painful thing, after doing all this work and so forth, right, is that you cannot extend this audit to future time spans, right? So this audit was 2014, 2016. What is the yield today? What is the yield in 2018 of the past year and so forth? No idea, right? And that feels odd, right? Because you put a lot of time and energy into doing the entire process, right? And you don't know what are we getting better or worse and so forth, right? And requires a renewal and audit. And these are very expensive, time-intensive resources in order to be able to run, right? So these are some of the issues that I think are brought up when you try to attempt a project like that. And of course, this is where we get to intersection, okay? Because we are obviously not the only group, the only clinical division or technology division to have these kinds of issues, and you gotta look outside to figure out how other people are solving it. So section 3, the keywords to a better way, and we're going to talk about 3 main things. This is a little bit more technical in terms of like what we're going to say here, but I think these are very important ideas to get a hold on. Index keyword search, sentiment analysis, and natural language processing as a general topic and so forth. So does it strike anybody as odd that you can search the totality of the information on Google? Right? You know, like Google expands, you know, if you can't find it on Google, maybe it doesn't exist or something like that. We make that joke about UpToDate, we make that joke about a bunch of things as well too, right? But there's a lot of information on there, and it comes back very quick, okay, right? And then there's certain very basic questions that you want to answer. The one that I especially feel strongly about, mortality, right, as the most basic outcome, if you want to talk about like to live or to die, right? Not always that easy to actually find out from an actual perspective. So there's a weird, almost like a divide between these two in terms of like, why can I run certain kind of queries very easily on very large sets of data, and then for very basic questions, we can't do it internally for clinical information as well. And one of the technologies that helps you out is a concept of an inverted keyword index, okay, right? So very basically, I mean, if you've ever picked up an encyclopedia, a book or a textbook, you look at the back of it, there's always that index, right? Like there's a bunch of words that you're interested in, right? You're interested in mitosis, so you're looking at the biology textbook and so forth. You look at the word mitosis, and it gives you all these little numbers of what page does it talk about that topic as well too. From a computer side, or from a search side, it's exactly the same idea as well too. So let's say you had 3 documents over here, just one sentence each, right? There's a concept called a stop word, which is basically these are words that are so common contextually, they're never important, they're never relevant at all. And then on the right-hand side here, you have this term called an inverted index. And that sounds like a very fancy technical term, but basically it's the same thing, like an index at the back of a textbook, right? So if I want to look up the word, retire, it's only really present in document number 2, and you can go back to document number 2. This core concept is super critical, Okay, and it may not, and this may seem kind of trivial to you, right? But this is, I'll tell you a little story about why this is so critical. Back in 2012, 2013, within the Department of Radiology, we've been doing traditional clinical radiology research for quite some time as well. When we asked our technology vendor, our risk provider, right, for reports that had a very specific sentence or phrase, let's say pancreatic cyst, or let's say there's a term called like muscular thickening that can be seen, hypertrophy secondary to chronic inflammation. So words and phrases like that. The response that we would get back from our vendors was the following, right? We can't do that. That's the first answer, okay? Oh, no, we really want it. Please do it for us. Okay, we can do it, but you got to give us a week to do it. And we have to do it on the backup of the database. It's going to take us a little while, right? A lot of manpower. It's going to cost $400. We'll get back to you, but we can't give you the report. We'll give you the numbers for the report, so you got to look up all the reports yourself and so forth. So that was kind of what we had faced, okay? Which, if you have even the slightest familiarity with day-to-day technologies and so forth, it felt very unreasonable. It didn't feel like it was a correct way about doing it. So a lot of the correct software. So if you go on, eBay, or you go to Craigslist, you're looking for like a new letter couch or something along those lines. The same way that you search that, using this kind of a concept, has multiple applications within information retrieval. And so what we were able to eventually do was form a direct access to a lot of the radiological information, put it through a concept like this of an inverted keyword index, and you have at the end of that a search engine, a very different I would say appliance or an application or a piece of software, where it's no longer this, here's what I think it could be, $400 and 1 week later, here's what your results are, you gotta look everything up and so forth, which is a very long time to iterate, right? You're looking at instant results, okay? And if this doesn't work, then let's try a different keyword, let's try a different search result too. That interactivity of being able to trial multiple hypotheses to see what works and what doesn't work and do it very, very, very quickly, right, is sort of fundamental. Right? I actually don't even know how we can, it is a miracle that we publish anything at all, right? Given what we have access to and how we access it as well, because we are, I don't know if it's a waste, but we're expending the lives of many, many people in order to get this information out as well too. So I think this is a very important concept, and once you use it, there's no way that you're going back to the older way of being able to run it. Yes?
Right, but the stop word list?
Yes.
So
if you think about it, if we converted every single word in all of these documents, right? You say the word "the," which is not very contextually relevant, right?
Those words are not relevant.
They're just it's your choice basically, right? So as you know your domain, you know your documents and reports in a certain way, right? So if you decide yourself that the word "the," I'm never going to search for the word "the," it's basically in every single report.
Because I see the word not.
Mm-hmm.
Not would be a very important word.
Correct. Exactly, I agree. Yes.
Okay.
So this is the overall list as well too. So if negation, which I think from a clinical side is extremely important, right, is relevant, that is a mistake. You do not want to program your stop lists in that circumstance as well too. It extends to more than just the word "not" in negation actually. Punctuation. Okay, so for example, in a radiology report, you usually have clinical history or findings or conclusion or impression and so forth, right? There's a colon, there's a dot right beside as well too, right? If you're not experienced and you discard that little colon as well too, you've actually thrown away information because that little colon actually indicates it's a new section of the document. Okay, so even subtle things like that as well too, and you only know if you know your own reports, if you know your own domain. So it's not a programmer that's going to tell you those little kind of nuances on that. It's actually whoever writes those things, writes those documents actually. Yes?
When you say you'll never go back to the other way of searching.
Yes.
I want to understand how you can search our current EMR that way.
You cannot.
Right.
Correct.
So then we kind of have to use the old way.
You do.
Right.
And it is up to you to decide whether that should be the case. It's going to be my message at the very end. That's the final thing as well, right? And it actually varies because and if you speak to some of the best departments, I guess like the most well-funded or well-structured departments, complete teams of people, right? Within the U.S. and so forth as well too, right? There's various levels of sophistication. Right, so there were a lot of radiology departments that could not search their reports. Okay, now there are many more. I would say there are commercial products that some departments have chosen to purchase. I know at St. Michael's in Toronto, downtown UHN, and that kind of thing. They have certain things as well too. I've seen a lot less progress from the EMR side, right? Because actually there's a lot more complexity. You can imagine the diversity of documents, handwritten or scanned PDFs, those sorts of things as well too. A lot of difficult challenges within the EMR space as well, but as we improve our processes, let's say from an ER perspective of data collection and capture, and it becomes more like typewritten or dictated or transcribed text and so forth, there are going to be very interesting opportunities from an outcome measurement perspective that will come as a result of all this, right? So a lot more nuances to this, but this is like, I think if you don't know this concept, right, you do need to know this concept as well, because once you start asking these questions, when a vendor comes back to you and says, oh, we can't do it, or it's going to take a week, and well, what exactly are you using? Are you using it in a very redundant or rudimentary way, right? Or do you take this kind of a basic concept? Open source, free. There are programs that will do these kind of things, right, from 2005 onwards. This is not new stuff. This is very, very mundane stuff from a computer science perspective. Second topic I want to get into is this concept of sentiment analysis. Does anyone recognize this term at all? I'm just kind of curious from the audience perspective as well. A tiny bit from there as well too, right? You may encounter this term in a very different context. Usually you encounter it from a marketing concept, right? So if you talk about, let's say, like Yelp reviews of restaurants and so forth, like are there people like this restaurant, or they not like this restaurant, or let's say like are they positive or negative tweets, or are they like let's say there's like abusive tweets and that kind of thing. So that kind of concept comes up as well too. So maybe you're not familiar with some of those examples, right? But one example that I'm almost 100% certain that you're all familiar with, email spam, right? It's not really sentiment, it's not a feeling, it's not a conclusion as well too, but at the end of the day, when an email comes in, you kind of want to know whether is it spam, or the technical term for the opposite actually is ham, apparently. Is it spam or is it ham? Is it actually a good email, or is it like a spam email and so forth, right? And that's in some way or shape or form, it's sentiment. And I know all of you have in some form a spam filter of some kind, right? So you think about a document comes in, you got to figure out, was it A or is it B? And when you get into more nuances of how this is actually executed as well too, you can even go not so much at the document level, but even at a sentence level or at a word level as well too. So $200 are really fair price. That's a great comment, right? And then John Faraday was very nice as well too. That's a positive comment. And then the camera here, this is a Panasonic Lumix, right, is a bit disappointing. That's a negative thing as well too. So these are the kind of detail that these systems can actually get down into. And you can imagine now, so if I wanted to count the number of positive and negative PE scans, right, well, this would be pretty useful stuff. I can actually almost quantify and tabulate a lot of this information within a report or a document. And if you've had some experience, for example, let's say you ran like for literature search, right, Ovid and Medline, right, there are things about exploding in focus, where you actually go synonyms and try to tie it to a subject heading or a conceptual term, right. Those things are also fall under the domain of natural language processing. The concept I talked about earlier about the colon and different sections of a document, it's a concept called chunking. The word stemming refers to, let's say there are two words that start at the same, they're almost like different conjugations of each other, but the same concept applies to them, right? So you can shorten it to a stem and then search it in a more flexible way. Things that we're all very, very familiar with as well too, right? So if you've used your Google Mail app at the bottom, is making all these very, sometimes a little bit alarming predictions about how you should respond at the bottom. That's NLP as well too. So it actually works surprisingly well. I find it a little bit interesting. And obviously, things like Google Translate or DeepL, these language-to-language translations as well too. These is all in the same topic and domain. And when you talk to your phone, I won't say the name because someone might have their phone on with the voice recognition. This is exactly in the same kind of topic as well too. So we've actually run internal experiments in radiology to try to figure out, can we automatically process? We took a lot of variations, which we've already discussed, regarding both location and the various synonyms of the word as well too. But our experience has been that after maybe about 500 and really good, once you get to about 1,000 and above and so forth, you can get a classifier that's anywhere from about 91, 92% up to about 95% or so, which you might think that's not perfect, right? Like if I were a chart reviewer, I had a med student that was reviewing for me, and then like 5 out of 100, they were constantly getting classifications wrong and so forth. A little bit concerning, but I want to bring a very different concept too. So like from a certain clinical standard, not so acceptable, right? The thing is, when you make one of these systems, there's a line that says like solve it once, solve it forever, right? So when you make a classifier, so long as we don't change our vocabulary and we use exactly the same 7 synonyms as we do going now and into the future and so forth, this classifier will work. So in some sense, we are trading 5% of accuracy for a continuous performance indicator, okay? And that's not perfect. That's not the best. Like, it would be great if we could get 100% accuracy, but you can start reframing a lot of your questions and your problems in terms of, well, by giving up that 5% of accuracy, can I now ask a different question, create a different application? Yeah.
I have a question on with the subset that it's training on.
Yes.
So as you have different radiologists, for example, added to your pool, your language is different, and then your results will change in accuracy.
Yes, correct.
How do you deal with that?
I think that
is there a
if
constant retraining required?
I think that the only way to address that, and this is what we talk about as well too, is that like these systems cannot be static; they do have to be dynamic, right? So you can imagine that if the number one, I say you have to acknowledge the uncertainty. So I really dislike systems that make these predictions and say, you know, the yield is exactly 14.1. You don't know because the system was not perfect, right? So there's a range, there's an error bar on that. Sometimes that error bar might be too large for your application or audit purpose as well too, so it will not work in every single circumstance. But if it's narrow or if it's kind of a general measure as well too, and you do have the opportunity to give feedback and sampling, you say, you know, well, this is plainly wrong, or there's a subtlety you clearly missed and so forth, you got to feed that back into the system. So these are not, you know, static things, they're continuous things that have to be iterated upon and improved. So in the same way that, you know, let's say like you're listening to like music on Spotify, a subscription music service, where you say, I like this song, I don't like this, thumbs up, thumbs down, that kind of thing as well too. We need those kind of dynamic systems within our research tools in order to gradually improve, right? So you don't want to just, you know, buy something off the shelf and that's the way it is, right? You got to be able to tweak and customize it to your own particular need or purpose, right? But this continuous solve it once, solve it forever, I think is a very nice idea that I would like to see more manifest in clinical research. And we've known this for quite some time. So there were some earlier attempts that we had made back in 2015 as well too, using a similar thing. You have a bunch of keywords, you extract out different keywords and you index that out, and you try to do this. There's a machine learning concept called a support vector machine, but basically we took 1,000 reports that contained the word appendicitis, and we tried to basically do a disambiguation, right? Was it saying there was an appendicitis, it was a negative, was it just in the clinical history? So rule out appendicitis. Doesn't mean yes or no, it just means we're wondering about it, right? Also an atypical manifestation and so forth. And so this is when I talk about the diversity of language, right, this is the kind of stuff that you will end up seeing. So these are all the positive sentences you can see. And you can see there's some, you know, commonalities in terms that keep on coming up over and over again. This is an example of negative. So we talk about the importance of the word not, right? The importance of the phrase no evidence, I think, is super important, especially when it's close to the word appendicitis, right? And you can think about, these are the patterns and these are the things that, so machine learning is not magic. It's looking for a statistical correlation between some of these tokens and some of these other tokens as well too, in order to create that kind of classification, or even as well to, you know, rule out or suspected and so forth as well. But the point is that at the end of this, actually, using only even very few examples, 100 training examples up to about 200, 300, 400, out over the 500 as well too, right? You're getting pretty usable, pretty interesting accuracy levels without a lot of training. So if you are collecting data now, I think one very interesting question you have to be able to ask is that if you're collecting by way of a normal clinical audit, 500 reports, can you convert that into something that can now be a continuous indicator? Okay, so it's not so much that you're investing your data collection for this moment, but maybe you could create something that could actually run all of the time and give you a continuous metric, and then you have a different application. The questions and the applications and the interventions you're going to run are going to be substantially different. So after about 500 examples, 96% accurate for this particular case. Now, appendicitis is a little bit easier. We've had varying successes and not so great successes with different topics as well too. But you can imagine, you know, rule out PE, intracranial bleeds in types of formats, right? Stable or progressive lung nodules, you're trying to define a chemotherapy, the presence of a recommendation at the bottom of a radiology report, right? If there's a critical notification or there's a complication, let's say after like a lung nodule biopsy of a pneumothorax, right? There are things that you can maybe measure that you didn't have the time for, you didn't have the people for, you didn't have the resources for, but then if you do a little bit of investment in training here, you may be able to apply it out. And I'm sure everyone is, you know, super aware of it, you know, like for cardiac surgery outcomes for New York State, and this is kind of super landmark stuff, and you can see between different hospitals and systems, right? But this requires a lot of investment, a lot of reporting, a lot of outcomes to be reported in order to be able to get this kind of information. So if I tie it back to my PE concept, right? Imagine if you had an error range. We know that from an individual perspective, their yield was like, you know, 15.9%. This is their range. These are your trends, right? If you agree or disagree with these events, you can review, maybe give that feedback back, say that the system was broken as well, and you get this kind of iterative loop that happens. These are some interesting possibilities that result from these kinds of technologies. Applied to many, many other types as well too. You know, we talk about like appendicitis, aortic dissection, yield on that, right? Head scans, rare events over a long period of time that you would not even contemplate, even if you had a lot of medical students to try to go and do that audit, right? Maybe you could now attempt because you have a different kind of a technology. So the last concept we want to talk about is that, so we talk about searching, talk about reports and the language side of things as well too. So I just want to briefly go over this thing, and then I want you to reframe a lot of your questions and arguments regarding this concept of, well, if you're searching text, can you maybe search pictures, search images as well too? The whole, I won't get into the larger, you know, there's a very long, complex argument about AI and radiology and classification and so forth, but usually, if I give a brief summary of it, right, usually think of something like this, where you have a flat picture over here, you feed it through a neural network, you create an output, is this a cat or is this a dog, and that kind of a thing, and you scale it out, and obviously, like, revolutionary successes over the last, like from 2012 and 2014 regarding how accurate machines are now capable of doing tasks like this. If you look at literature regarding what a task is as well too, you get like all these very specific terms like image classification, which means the full thing, localization, which means that not only does this have a cat, this is the cat specifically here. You can do into like, sub details in terms of object detection and so forth. So you can do different classes and different objects and do counts, or even go to a full contour as well too. So these are the different terms. So you see this a lot for definitions. And one of the main ideas I'm trying to get across is that neural networks are not really necessarily applications in of itself. We have to dictate the applications, but they're building blocks. You can use them, tie them together, and to form some very, very interesting things. So here's an example I found was super interesting. Using deep learning and Google Street View to estimate demographic makeup of neighborhoods. Okay, so this is actually a collaboration, I think, between the Berkeley Computer Science as well as like some researchers at Google as well too. And if you look at this, is more a social science concept. But if you looked at what they were able to try to tie together, is that if you imagine just like you look at those cat and dog pictures as well too, you have these street view images over here, right? You have vehicles, which you can find as a classification, that's a car, right? So an object over there. And you can even sub-classify that car as well too. So what kind of a car is it? What year is it? What is the like the trim type and subtype, and what is the price in the vehicle and so forth as well too. Now, imagine that Google has all of the street view information. They have a normal distribution between daytime hours of all these vehicles distributed across the country as well too. You now know all of the vehicles that are present, and you map that out, right? And you have the surrogate measure as well too. So maybe the Honda Civic, that 8,773 can be correlated to a particular socioeconomic status within that neighborhood, and you can actually map that out at a resolution, at a scale, at a level of detail that is completely infeasible by any other means and standard as well too. And this is super interesting stuff that I think that, so you might think about how you can tie this out back and you relate this back in from a medical perspective as well too, right? So exactly like would you do a survey? Would you go door to door? Like how would you get access to this kind of information? Really not possible by a conventional method, okay? So I want you to redefine this idea of search, not just in the text perspective, but also maybe from an imaging perspective, from a picture perspective as well. So this thing you can't measure, you now can maybe measure as well too. So what we've tried to do within radiology actually is like try to get very, very familiar with these methods to better understand them and figure out what we can actually do and apply them for as well too. We have some early projects where we're trying to do, like, for example, like automated liver volume quantification, trying to figure out does fatty deposition or not, quantifying, like breast density and so forth, and doing it at a particular accuracy, right? So very, bite-sized steps as well too. But the technology that we're working on has evolved to a place where we're going to be able to do forms of localization as well too. So we have one project that's working on, for example, let's say like TB and acute formats as well too, trying to localize where exactly disease is. There are limitations to this. We know that these do not work in a lot of different cases. We have a lot of failure examples as well too of misclassifications as well. But we're trying to get to see what is possible, what is not possible as well too. And you end up with these things that look like heat maps, localization for a cavitary area across over there, and some sort of form of activation. The technology is getting to a point now actually where we're actually even able to leverage existing information from a public competition data set, pre-train a network, customize it locally on McGill information as well too, and do almost like location and localization propositions as well. So this is done on our local MUHC data sets as well. And so you can now begin to see that some of those earlier examples we were talking about, which is just social science research and Google Street View and all that kind of stuff, right? The ideas that you have over here, if you have this corpus of information, imaging information as well too, you can now measure and quantify certain things. So I was thinking about different concepts as well too. Let's say like let's say I had a question, malpositioned Doboff tubes, which is another topic that's come up for like internal medicine and so forth, right? If I wanted to start quantify that, can I even like figure out like where the manifestation is, where's the location of that, when does it occur, and so forth as well too. I can now start asking those questions not just in the text of the report, but maybe even from an imaging perspective as well too. You have a very bright marker that's very easy out to segment as well too. So very different kind of an idea, but I think these ideas of searching, right, they apply both in the visual space as well as in the textual space. The last point I'm going to bring up about these networks as well too is that there are two terms that you have to be familiar with: training versus inference, right? You have to be more involved in the engineering side of these things as well too, right? You've probably heard you need big hardware, lots of supercomputers and expensive video cards and so forth to be able to run all this AI stuff and so forth, okay? But that is a specific term. It's on the word training, which means that when you actually go and do that initial calibration of a network, that's going to take possibly hours, weeks, sometimes stretching out to months sometimes as well too, right? So that's the very expensive component from that perspective. But once you have trained and configured a network, the other term, which is inference, which means that prediction of where is the cat pointed out, where is the cavitary lesion on that chest X-ray pointed out as well too, right? These things take milliseconds. Okay, so some of the scores across over here, like so per localization event, right? You're talking about like milliseconds between about 50 to about 172 milliseconds. So if you wonder how you pick up your phone and you find like a QR code, right? And you try to do a recognition on that, right? Or you do like some sort of like classification or detection on that as well. It happens on a phone. It's a battery device. It doesn't have that great of a processor on it as well too. It can happen very, very quickly. And it's that second half of it, of the idea of how you can infer very, very quickly once you've done the initial training, that can actually open up a lot of very, very interesting applications. So what would be, from your project's perspective, an implication if you weren't limited to searching just text, but you could do it to an image record as well? I think something to think about. So conclusion for final words and so forth, right? I didn't really want to push on that one topic of rule out PE and that specific topic as well too. It was one example, but what I want to highlight is this analysis of the process and maybe reworking using technology borrowed from other domains and pulling it into our domain to solve very clinical research problems as well too. So it's more about the process and really is about that specific case or that particular topic. And the question is, if we change our process in some way, can we ask more questions, better questions, get faster results, iterate much faster as well too? And I think the ideas from other fields we need to borrow locally. And then that second concept of how if we do have small amounts of curated high quality information, can we just get more use out of it, right? So instead of just publishing that one paper, two paper out of that curated data set, right? Can you take it, reflect it, translate it to other hospitals and domains, right? All these things would be very exciting to be able to run as well too. And it's more about the function. I don't really care so much about the specific technology. I love the technology, but what can I do with it? What could I not do before that now I can do? I think those are sort of the important things. So we started out with intersections at the very beginning, and we're going to get back to your earlier point here, because the second road sign is a fork in the road, which is the opposite choice as well. Because we actually make these choices constantly with our project designs with respect to whether, should we get the grant, should we get the, the team and the assistant, the technician, the programmer, all these kind of things as well too, right? But the question that we don't really ask is that, like, given those resources, right, like what can I accomplish, right? If I completely change the paradigm entirely, right, maybe we can do something completely different at a different level of efficiency as well too. So is that favorite, that Ford quote, right? If you ask people what they wanted, right, they'd probably respond, they want faster horses, right, as well too, right? Maybe we shouldn't be purchasing horses. Maybe we should be purchasing other things, right? Electric vehicles, let's say, less emissions. So I think these are the ideas and concepts that I wanted to bring forth, right? And I think it's important to bring it to us from a scientific community side. We're working a lot of things internally within the department as well too, and I really want to see these ideas manifest in a lot of other people's projects and concepts as well. Okay, so that's what I mean. Like, I think that we're doing things okay. It could be substantially better, but we have to be open to other ideas in order to be able to improve. Thanks so much.
Any questions?
Yes.
So you are aware that the hospital is building a data warehouse, right?
Oh, sure.
To your mouth, to your mouth.
You have to put it very close to your microphone.
Let's go to the top.
And speak more slowly. So the hospital is building a data warehouse.
Mm.
Is there any talk about integrating this into the data warehouse? Because that should be our future.
Yes, I think that. So I think the phrasing of the question or the comment was obviously I brought up the data warehouse, right? Which is a concept long in the making, actually, from the MHC perspective, is in progress, is being developed right now. And the question is, like, can we integrate some of these ideas directly onto the data warehouse? 100% absolutely yes, of course. Okay. The concept of a data warehouse is not just for MUHC. If you try to find other institutions that have successfully implemented a data warehouse, it's not, strictly speaking, just a technology problem. I think that's one of the important things I want to say about data warehouse, right? There's a very, this is something that gets drilled into you from like the health informatics side and so forth, right? There are other elements, right? There are people, there's governance, there's ethics, there's a lot of other things that go involved. And actually sometimes those elements of the management are substantially more difficult than the technology. So if you flick the switch and you connect up the databases and you hook it up to an indexer or some kind of, you can get these things very, very quickly, right? But are those aligned with your institution's values, with the patient's values, with all the other values as well too? Those things are very difficult questions to be able to answer as well. A very big thing that actually that has proven very troubling as well too, or very difficult to navigate around as well too. We talk about commercial versus non-commercial research as well too, integrations of that. The radiology department gets requests from startup companies and all sorts of things for access or collaborative research and so forth as well too. These are extremely difficult things to navigate. There's actually very little precedent for a lot of the requests and things and so forth. So I think that those things, the ideas from the technology side, so this is why I think it's important. You have to be aware that the technology can run it, but that being said, there's another half of you that has to ask, what can I do or what should I do versus not? Okay, and the thing is that if it is aligned with those values and with those systems and is actually for a good purpose and a correct purpose as well too, conversely, you should not let a technology vendor say it's not possible, right? So it's sort of like there's almost different sides to spin on that as well, right? And so maybe earlier in the story in the timeline I was talking about was actually the opposite problem, right? It's that we thought it was possible, the vendor did not say it was possible as well too, or was very difficult, right? And so then you need to kind of be proactive and pro-technology on that side, right? And then you run into the opposite problem, which is that you can be, like everyone else is pro-technology, and you're like, well, wait a second, there are different considerations here that we need to take into account, and you need to almost attenuate and control yourself on the various roles.
Thank you. That was really great.
Mm-hmm.
Just with regards to the PE
yes.
question,
Mm-hmm.
It would be great. It would be very interesting because you mentioned, this is one of the drawbacks potentially of AI is not being able to capture certain nuances.
Yep. Okay.
So in your situation, the pretest probability or the well score.
Right. Right.
And in fact, that number could be very different if those numbers that you showed by volume, for example,
yeah, exactly.
really should be divided according to what the pretest probability was,
yep.
rather than just raw volume of scans. In terms of being a very informative number, and if a physician were to get a report card, for example,
yep.
the real question you want to know is how many appropriate scans were done, not how many scans were done in the overall positive and negative, but how many were appropriate. Because, like you said, this only occurs 1 in 1,000.
Yes, exactly.
So nobody's going to only order, that one test to find that 1 in 1,000. That's impossible. But you would want to know that a physician actually appropriately ordered a certain number of tests.
Right.
So could you not train the data to develop a well score equivalent?
Right.
Have you looked into that? I think that would be really interesting.
As a surrogate measure as well.
As a surrogate measure.
Yeah, exactly.
For
Yep.
pretest probability, because I think that's an area.
I think that concept actually, that question and the concerns raised as well to we in our own internal discussions, we definitely had major issues with that as well. That was the missing element, like that substratification of what taking into account the wells, right? What we actually wanted to show and what we think is explanatory of the different yield across those strata, right? Is that the only way that you get a yield of 3% is if probably the vast majority of the patients that you're choosing to scan are low probability, low pretest, right? That is, I think, the very obvious and a natural conclusion, but we would need more data to be able to run it. There is actually there's a philosophical debate or different camps that are actually occurring within radiology, and you see different things coming from the US side versus the Canadian side and so forth, right? Of can you address these issues prospectively versus retrospectively. And you'll notice that the way that this was operating on, it was very retrospective, right? Like, so you had the data from the back. There is a completely different philosophy in terms of, I guess, addressing this issue of appropriate utilization, which is almost from the order entry perspective, right? So, and you got to think about it from almost like a private or from a private insurance payment model and that kind of thing as well too, right? Which is that this is a checklist. These are the questions we're going to ask you. If you do not have a positive answer for all of these different questions, it's not indicated, you're not authorized to go ahead and so forth. It's a very different mentality and mindset as well. And so there have been many technologies that have been deployed on the prospective side. And for more cultural maybe or institutional reasons as well too, the reason why this project was designed in a retrospective sense as well is that we actually think that there needs to be a balance between both formats as well too. There are things that you can do from a prospective end. Let's say I need a well-scored number beside the requisition before you order, and we're going to put that in. So that's a prospective approach to it as well too. And the retrospective end has a certain benefit in terms of we can get historical norms and data, right? We can go further back in time. We can kind of scale out to multiple centers maybe. If you do it at a provincial level or like a national level as well too, it's a little bit easier to do that retrospectively as opposed to going into each individual hospital and changing their prospective processes, right? So there needs to be probably a combination of both styles or techniques, right, in order to get traction on the actual, on the final problem. Your specific comment about trying to create a pretest probability, integrating all of the information, that's sort of holy grail kind of topics. And so we, from the radiology side, we see, like you get these like pitches and promotions like from IBM Watson and that kind of thing. We'll pre-read all the records. We'll give you all the information before you even do that scan. It's going to give you a pretest score and so forth, right? We've even discussed the concept as well too of like using a well score, which is any other kind of calculator system as well. That is off of a study population data set. What if you had a system that could both model your historical performance and preferences and biases and so forth in conjunction with the patient information that is the one patient that is directly in front of you, right? And everything else that every blood test you've ordered on this person and so forth, and integrate it all together. So maybe in a standard study population, your pretest probability is going to be between about 10 to 15%. But taking what has happened for you specifically into account, right? You're an oncologist, right? And quite frankly, your yield is substantially higher than everybody else. So that rule works for the general population, but for you and what we know about you and your practice, right, is actually going to be a little bit higher or a little bit lower in the opposite sense as well too. Right, so that's a kind of, and these are extremely high-level modelings and questions that we could ask, right? But we're just struggling to get that one number to begin with as well. But I think that if you can imagine some of those possibilities as well too, it would be very, very practice-altering, very, very different in terms of from what we currently do right now, which is at best we try to follow a rule, we try to educate others about certain rules and patterns, right? And we fail to take a lot of those nuances into account. And Dean, yep.
Thank you, Jaron. You kept the talk at a very interesting level. I like that slide where you said what took a year should take just 30 minutes.
Yep, correct.
I think we're all waiting for you to achieve that.
Yeah, I'm working on I'm working to get that down to about 2-3 months or something along those lines. It's something faster. Yeah.
Actually, that is my question because listening to everything you've said, it seems like the technology is not difficult to acquire. The methods are mundane.
Right, right.
What's
What is preventing us from getting the 30-minute goal?
The manpower. You said people who actually write these reports are people who need to curate and make those inverted indices.
Yep.
Or what is the Department of Radiology doing to further that?
Right. Okay. So if we talk about existing barriers right now in terms of like, so let's say you had this dream, like I want to be able to repeat this project in 2018 in only 30 minutes and so forth, like what needs to happen from a specific perspective? I think one of the major issues that we're dealing with right now with respect to, there's a term in big data called velocity of information, which is like how quickly can you update, how quickly can you get that information in databases. So our databases from the research side go up to about 2017 and so forth, but regarding what happened yesterday and what happened in the last 3 months, let's say and so forth, it's only maybe in the last few months where we have maybe a concrete plan on how to get that kind of a live or direct access. There's a few options that we're pursuing within radiology, but it's getting to a point where we have like what was historical latency, which is they say a year or 6 months off, right? We're going to be able to start bringing that down to a month to a week to within like 24 hours after a report is signed. So there's a technology element there that's we've been trying to solve, right? The second thing that's underappreciated is that although you can run a lot of these classifiers and train a lot of these models very, very quickly, and I've put up these graphs and charts and so forth, right? What exists right now is that each of these different programs that we've made to do these kind of sentiment analyses and classifications, they're custom made each time. Right? So the program that was made for the appendicitis in 2015 is not the same program that was made for PE classification in 2017, right? It keeps on being retweaked and recustomized each time. And what there needs to be a certain maturity on, I think, going forward, especially if other groups are also working on similar kinds of topics and things, right? You almost need like a common platform. Right? So as simple as it is right now to fire up a MS Access database and you create a little thing on there, right? We need that kind of a platform or a site or an equivalent, right, that can run these topics in a very conserved manner. Okay, so I think the tooling, I think the kernel, the theoretical possibility of doing that sort of classification, the evidence supports it, right? But the tooling and the infrastructure around it as well too is going to require a lot more development. But we are improving from where we were from a year ago.
I'm just going to make one last comment, mostly because in my last year I've made a lot of connections with the Department of Computer Science at McGill. And I think as clinical researchers, we don't really reach across boundaries very much. And I've actually gone to the McGill main campus. I haven't been to McConnell Engineering since I was an undergrad. But there's actually a lot of domain knowledge in these things and students and stuff like that. And they're so overstretched because of the boom in AI in Montreal in terms of applicants that want to have projects. They don't have enough supervision. So, I've been approached to be co-supervisors for people in the Department of Computer Science just because they need kind of direction of what type of project is important. But I think that that's a good opportunity to get some of this stuff off the ground in the ClinEpi field that we haven't really used as much as we can, because there is a lot of expertise in that department.
Yep. I think you need to communicate your issues, your problems, and tell them to people. Tell anyone that will listen to you, right? Because what you may find completely insurmountable might be absolutely trivial to that second-year undergraduate student, right? That is working in a completely different department. Right? You might be surprised, right? And that's what I've been surprised by constantly with this as well too. And and I actually have gotten that question from other radiologists across at our national society meetings and so forth, right? The other thing that's kind of funny as well too, it is actually possible that the problem that you have that you bring to one of those partners and collaborators is too simple, if you can imagine as well. So some of these topics are actually so old, so out of date, or the problems that we face as clinicians, right, are so old and out of date and so simple that from a novelty perspective, it's a very tough sell and argument to a computer science department as well, right? I think that's a very funny thing that you actually encounter, and so you have to find the right partners and strike the right balance of someone that is less theoretical, more applied, and so forth, right? But then when you can find that match, right, it results in very, very interesting things and completely different ways of doing and approaching problems than you would normally expect. Yep. Okay, well, thanks so much.